You are welcome to the GMAT 41's Organic Chemistry 1 class. In this video, we have some compound structures on the board whose nomenclature we are to give. Now, in our previous class, you would recall that we explained the concept of types of alkyl substituent, where of course we talked about the primary and the secondary iso alkyl substituent. We also talked about the tertiary alkyl substituent. You would recall that, right? Good. We stated that in the next class we are going to look at structures where we'll use the knowledge from these types of alkyl substituents to explain. And on this basis, we have these structures here on the board. By the time we are done with these structures, it's expected that once you encounter any complex aliphatic structure, aliphatic compound structure, you will play with it. It will become like a game for you to have fun with. Is that okay? Now we're going to use this knowledge from the previous class to give the nomenclature of these structures. Are you ready? Come with me. Let's take the ride as we play around these structures on the board. Meanwhile, recall that from previous classes, we've explained and established general rules that you have to follow when trying to give the IUPAC nomenclature of a given structural formula. Structure number 5. Look at this on the board. This is number 5 because we've actually treated some structures before, 1 to 4. Is that okay? So we're continuing to add up to the structures we've learned so far. Remember, still dealing with what? Alkanes. Okay, now look at this structure. The first thing we have to do is to determine the longest continuous carbon chain. And how do you actually get the longest continuous carbon chain? Although from previous class we've stated that before, but I'm still going to repeat it. You follow the direction of the bond lines, the direction of the link from carbon to carbon to carbon, and check which one is the longest. Now we can actually look at this structure and you'll agree with me that this straight chain is the longest carbon chain. Find out for yourself, just look at it. The next thing now is to ask ourselves, alright, if this is the longest carbon chain, am I actually supposed to count from left to the right or from right to the left? Are we together? And you would recall that I gave the explanation to that the direction you count from depends on where you cite your attachment first, where the attachment is closest to. Is it closest to the right or to the left? That was what we said. Is that okay? Now if you look at this, if I count from left to right, number 1, number 2, on the second carbon atom you have this methyl attachment. Alright, now let us count from right to left and see. From right to left, number 1, number 2. On the second carbon atom, you have this bromine attachment. Oh my God, this is actually a terrible structure, right? There is a problem here. And what's the problem? That from either direction, you locate your attachment first on the second carbon atom. It therefore means that your attachment is closest to both ends. It's closest to both ends. Is that okay? Now, let me show you something. Suppose there is no other attachment here. You know that this bromine is another attachment. This compound here, this part, is also another attachment. But let us assume that this attachment is no longer there, and this one also is no longer there. You only have this bromine and this methyl. And you notice that you cited both on the second carbon atom from left or from right. What will help you to know where to count from is the alphabetization rule. The alphabetization rule, looking at it, bromine starts with B, methyl starts with what? N. Therefore, your counting will start from the right because B comes before N in the alphabetical order. However, in this structure we have on the board here, you see that we have other attachments. So how do we determine where to count from? We can go further. Second carbon here, you have a bromine attachment. Second carbon here, you have a methyl attachment. Now, if I go further, on the third carbon atom, I have another attachment. Is that not so? That's from right to left. But from left to right, on the third carbon atom, you do not have any attachment. You do not. And that simply means that the actual direction to count from is from right to what? Left. Not left to right. Now, this is actually a trick, a fast lane you can go about knowing where to count from. Is that okay? Without numbering your whole carbon atoms and then going by saying which one gives the lowest sum to the attachment. You know, we have a rule like that where you count from the direction that gives the lowest sum to the attachment. Alright, now I would like to make the whole analysis for this structure. Is that okay? Just to guide you once again, although we've done that before, but I'm going to repeat it. Now let us number from left to right and from right to left and see the one that gives the lowest sum to our attachment. Let's see how it goes. From left to right, carbon number 1, 2, 3, 4, 5, 6, 7, and 8. Then let us go from right to left. 1, 2, 3, 4, 5, 6, 7, 8. Did you take note that from left to right, this direction, from left to right, so let's say LF. On carbon number 2, you have this methyl attachment, so I'll identify position number 2. On carbon number 5, you have another attachment, and then on carbon number 6, you have another attachment, then carbon number 7, you have another attachment. If you add all these positions, 2 plus 5 will give you 7 plus 6, 13 plus 7, 20. Now let us see what happens when we count from right to left. That's right to left. Let's see what happens. On the second carbon atom, following the blue marker, we have an attachment, so 2 plus. On the third carbon atom, we have another attachment. If you consider this thing now, for that of the red marker, that is left to right, you notice that the second position of attachment is 5. But then, that of blue marker from right to left, the second position is what? 3. That simply tells us that counting should start from the right to the left. But anyway, let's see the end of this. On the fourth carbon atom, we have another attachment. And then on the seventh carbon atom, we have another attachment. Let's add up. 2 plus 3 is 5. 5 plus 4 is 9. 9 plus 7 is 16. 16 and 20, which one is the lowest sum? 16, you are very correct. Therefore, the correct direction to count from is from right towards left. I've given all the rules we need regarding how we determine where to count from. Let's take a short break. As we go on this break, sip some water. You know, chemistry said that water is a universal solvent. Use it to dilute, the brain. While you think about the explanation I gave regarding how I determine where to count from, the correct way. Remember, we have selected that it's from right towards left. When we'll come back from the short break, we'll now give the IUPAC nomenclature of this structure. Taking note that this is an attachment, this is an attachment, this is an attachment, and this is also what? An attachment. We'll be back. You are welcome from the short break. Now, let us give the nomenclature of this structure. Is that okay? Now, how do we go about it? I'd like to state that this structure can be named in 2 different ways, which eventually are the same. Alright? So let us look at the way we can name them. Remember, our counting is from right towards left. That's the correct order we already approved before we went for the short break. So let us see that. Remember that to give the nomenclature at this point, you have to locate all your attachments. And then mentioning the attachment, following the alphabetization rule. Okay, let's go. On the second carbon atom, we have bromine, which is bromo. On the third carbon atom, we have bromine, which is bromo. And then we notice that on the fourth carbon atom, we have this attachment. Look at this thing very well. This is a substituent on substituent. You remember our father, son, and what? Grandchild. Mr. A, Mr. B, Mr. C. You remember that illustration, isn't it? Now notice that this carbon atom, look at it, this carbon atom is directly linked to carbon atom number 4. Please take note, it is the blue marker numbering that we are using. That is from right towards left. So on the fourth carbon atom of the parent chain, we have this attachment on it. But this attachment, like I said, is substituent on substituent. This is the parent directly attached to this carbon number 4. You can see this carbon is like a parent on its own directly attached to this carbon number 4 of the main parent. Does that make sense, right? So this is just like our Mr. A. Then Mr. B, alright, you have to number it again. Remember the rule that when you have attachment on attachment or substituent on substituent, you number it again, starting from the carbon directly linked to the parent carbon atom. So I will go, this is number 1. Now I can either go to the right, number 2, or go to the left, number 2. Either way you have a longest carbon chain on that substituent on substituent. So let me go to the right and see. So I have 1, 2. Now, if that is 1, 2, it therefore means that this CH3 is an attachment on this parent. Are you following? Remember our substituent on substituent illustration. So this is just like Mr. A. Now, carbon number 1 is Mr. B. That's carbon number 1, 2 here is Mr. B. But this Mr. B, which is 1, 2 carbon, gave birth to Mr. C, which is the grandchild now, CH3. Are you following, right? Good. So this is attachment or substituent on substituent. Another thing that will help you to quickly identify a substituent on substituent is this. Once you get that carbon atom directly attached to the parent, check if it has 2 or more branches away from it. That is, if it has 2 or more carbons attached to it from different directions. Is that okay? All this will help you to know that. Okay, now let's go. This substituent on substituent is 1-methyl ethyl. You know that these 2 carbon atom and it's an attachment, so it is ethyl, an alkyl attachment. But on this ethyl attachment, you have CH3, which is methyl, attached to carbon number 1. All of these principles, we've actually treated them in our previous classes, in our previous videos, alright? And so let's see how we go about that. So we've identified this to be a substituent on the 4th carbon atom, and this is 1-methyl ethyl. 1-methyl ethyl. The next attachment is this, which is on the 7th carbon atom, methyl attachment. So how do we actually give the name of this nomenclature? So let's do that. We're going to have on the 2nd carbon atom, we have bromine attachment, and on the 3rd carbon atom, we still have bromine attachment. That's going to be 2,3 dibromo. 2,3 dibromo. Then we move on. You see, if I have methyl and I have 1-methyl ethyl, which one should come first in alphabetization order? That methyl will come first. Because if you look at methyl ethyl, after the methyl, the spelling still continued. Is that not so? Which means that this methyl will come first. There's something we do in what we call, I think, verbal reasoning, where they talk about arranging words in order, in dictionary order. Are you getting it? So if you have methyl, methyl will appear first before methyl ethyl. Is that okay? Because methyl stopped at the spelling L. But you have methyl ethyl, which is what we have here. After the methyl, it still continues the spelling with ethyl. It therefore means that this will have to be pronounced first before this. Is that okay? So that's going to give us 7-methyl, 7-methyl, 7-methyl. Then we'll come back here. This is substituent on substituent. What do? You identify the parent carbon atom bearing that substituent on substituent. Now it's on the 4th carbon atom. Then open brackets. You recall the principle was already explained in previous classes. This substituent on substituent will be put in parentheses. Alright? And we said that the name of this substituent on substituent is 1-methyl ethyl. 1-methyl ethyl. 1-methyl ethyl. That's that. We are done with that. Now the longest carbon chain is what? 8. So this will end with what? Octane. We're going to take a short break. Look at how we came about this structure. When we'll come back from the break, we'll give the alternative nomenclature to this structure using the concept of isopropyl, because this is actually an isomeric propyl. Isomeric propyl. Let's go for a short break. Don't forget to take your water. You need to dilute your brain, okay? Once again, you're welcome from the short break. We now want to give the alternative nomenclature to this structural formula, and this name we're going to make use of the common name supposedly referred to as the old name of this substituent on substituent. Alright, you recall that we treated it when we actually discussed the concept of types of alkyl substituent. Is that okay? Everything will remain the same, just a little adjustment at this point. And what's the adjustment? The name we give to this. Remember, in the IUPAC system, the name of this is 1-methyl-ethyl. But I'm going by the common name. How many carbons do we have all together here? How many carbons? 3 carbons. Is that okay? Now look at something here. Do you know that this is C3H7? This attachment you're seeing here is actually C3H7. Look at it. And C3H7 is an alkyl because C3H8 is alkane, propane. But if there is one hydrogen missing, which reduces to H7, it becomes what? Alkyl group, which is propyl. But the reason we cannot name this, we can't call this propyl directly. If you call it propyl directly, you are actually not in line with the rule that guides this. You can't call this propyl directly because of this. See, if this were to be propyl, then this carbon atom that is directly attached to the parent, are you following? To parent carbon number 4 would look like this. It will be CH2, then linked to carbon number 4. CH2, are you seeing that right? Then it will not, which means that maybe one of this hydrogen will be attached to this hydrogen to make it CH2. Then this CH3 will now be linked directly this way as CH2 and then linked to CH3, which is the last one. We actually showed this when I explained the concept of normal alkyl attachment in our previous class. So I encourage you to visit the previous class and say that when we treated type of alkyl substituent, the first one we said that we're going to refer to it as normal alkyl attachment. So if this were to be propyl straight ahead, this is actually how it's meant to look like. But this thing is not like that. You see that there was arrangement of hydrogen atom. One hydrogen atom was removed from here, added to this, making it CH3, and that CH3 come backward to attach here. So there is an arrangement of structures. And you know, when you do arrangement of carbon atoms, hydrogen, you know, in organic compound, we refer to that as isomerism, which means that this is propyl, but not a normal propyl. Rather, isomeric what? Propyl is an isomer. And on the basis of that, we are going to now give the common name of this structure. Remember, when you are dealing with isoalkyl attachment, that I is respected, is considered in the alphabetization rule. I mentioned that again in our previous class. So I urge you, please, make sure that you've watched and replayed the videos of the previous class. It will help you out here. So let us go in the alternative name. So I'm going to write or. I'm going to write or. Remember, this is isopropyl. So it's going to be 4-isopropyl. Now let's look at this. This is bromine, bromo, B. In alphabetical order, B comes before I. But you know that I comes before what? N. Which means that this methyl will be the last attachment mentioned. The order will be B, I, and N. So let's go. That's going to be 2, 3. Between number and alphabet, you put hyphen. So have dibromo. Good. And then we move on. On the 4th carbon atom of the parent, 4-isopropyl. And then on the 7th carbon atom, we have methyl, 7-methyl. The longest carbon chain is 8, so it ends with octane. And that is the nomenclature of that structure. Either of them is correct. If you sit in for exam and options are given, 2 of them cannot be given in the option. It's either this is given, you won't see this there, or this is given, you won't see this. Please play around this, watch the video again and again. If you have any question, you can always, it's your right, inbox your question to GMAS41's CRSD number. Now let us look at the next structure, number 6. Okay, so let's do this. Once again, we're going to say if we have 2 alternative names, alright, for this structure. First, identify the longest carbon chain. I'm going to identify that quickly. The longest carbon chain goes this way. Remember, you need to follow the bond lines. Look at this. 1, 2, 3, 4, 5, 6, 7, 8. Look at how I went. One might choose to go this way again. Maybe if you are confused, just to confirm, because that direction also looks longer as well too. But I guess if you go there, let's see, 1, 2, 3, 4, 5, 6, 7. Of course, 8 is longer than 7. Good. So the longest carbon chain is this chain. The next thing is to number. Are we to number from here, going this direction, or number from here, coming this way? Looking at this, if you go in this direction, the first attachment is seen on carbon number 3, which is this methyl attachment. Are you seeing that right? If you count from this part, coming this way, again the first attachment is seen on the third carbon atom, which is this methyl attachment. But if you go further, on the fourth carbon atom, you have this whole attachment. Is that okay? But if you come this way, on the fourth carbon atom, there is no attachment. Therefore, the correct order of counting would be from this side, alright? Coming this way. You can just go through, number everything, maybe left to right, right to left, and check the lowest sum to the attachment. You will agree with me that the correct order of numbering would be 1, 2, 3, 4, 5, 6, 7, and 8. So this is actually going to be an octane compound or octane alkane member. Remember that any carbon atom or any other atom or group that is not part of the longest carbon chain becomes an attachment. Therefore, let's identify our attachments here. This whole group is an attachment. And if you look at it, you agree that it is substituent on substituent. Because this carbon is directly linked to this parent, number 4. But on this carbon, there are 2 branches. You can see that 2 carbon branches attached to it. So it's substituent and substituent. This CH3 was not counted amongst the parent chain, so it's an attachment. This is also an attachment. Good. Let's not give the nomenclature and say. Going this way, remember this is methyl. This is also what? Methyl. Is that okay? If I am to give the IUPAC nomenclature, because I'm going to give IUPAC nomenclature as well as the common name. Still IUPAC anyway, but this part we will use the common name for it. So first, let's follow the full IUPAC nomenclature, also considering this on the IUPAC nomenclature system. You know that this is methyl, this is methyl. Methyl will come before this. This one is 1-methyl ethyl, just like we encountered in instruction number 5. We are going to number this again. Let this be number 1, and let this be number what? 2. Therefore, this will become what? Another attachment. Substituent on substituent. Grandchild. Mr. C. Am I communicating? All these terms I use is just to create a lasting impression in your mind when you are studying this, or maybe after you must have watched this video. So we go, this is 1-methyl ethyl. On the basis of that, the structure here is going to be 3, 6, because 3, and on the 6th carbon atom you have methyl there. 2 of them, so it will be dimethyl. Dimethyl. Then on the 4th carbon atom of the parent, you have 1-methyl ethyl. 1-methyl ethyl. Then the longest carbon chain is 8. So that's going to give us octane. Or the structure can be in the other way around. Where if I'm using the common name of this, you know this is isopropyl. Isopropyl. I comes before N. Therefore the structure will be 4-isopropyl, 4-isopropyl, propyl, 4-isopropyl. Then on the 3rd carbon atom and on the 6th carbon atom you have methyl attachment, so dimethyl, and then octane. So any of this structure is taken as the IUPAC nomenclature of this structural formula. That is any of these name. And now I want to look at structure number 7. Alright? Wow. Maybe you are wondering, what's this? I've not seen this before. Please just take note that this is also another model of writing the structural formula for organic compounds, be it an aliphatic compound, or if you're studying aromatic compound, or even cyclic compound. For example, if you have something like cyclopropane, is there any, okay, let me just squeeze it in somewhere. Cyclopropane, you have something like this. So we could have a model like this in writing the structural formula of organic compounds. It's pretty easy, so don't feel threatened, okay? It's a simple one and you can do it. Together we can work around this structure and give the nomenclature. Now, what should you know about it? So let's do that and see. At each point where you have maybe ending of a line or two lines meet, there is a carbon atom at that point. That is the trick to this. Is that okay? It therefore means that there is a carbon atom here. Let me locate. There is another one here. There's another one here. Then this. Now there is a line here. So this, a carbon atom. Then this line is already connected to bromine. This line is already connected to bromine. This is already connected to bromine, to chlorine rather. This one is not connected to anything. Therefore, at this end, we have carbon there. That is all. So it's very simple. Now, how do we go about this? As usual, we determine the longest continuous carbon chain, identify our attachments, follow the alphabetization rule, and give our nomenclature. So let us look at this. This is an attachment. This is an attachment. This is an attachment. What is the longest carbon chain here? If you count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the longest carbon chain, although this is also a carbon atom, but this is an attachment as well too. So let me circle it. And in fact, once you see this like this, it represents CH3. That is methyl attachment. Is that okay? Alright. Now the question is, there are 9 carbon atoms in the longest carbon chain. Fine. Now, where do we count from? Is it from here or from here? And you know it depends on where you locate your attachment first. Counting from here on carbon number 2, you have chlorine attachment. But counting from here on carbon number 3, you have bromine attachment. Therefore, the correct direction to count from is this. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Fine. Now you notice that on the 6th carbon atom and on the 7th carbon atom, we have bromine attachment. So that's going to be 6,7 dibromo. And then on the 2nd carbon atom, we have chlorine attachment. Of course, you know, before you mention this methyl, chlorine would have to come first, following alphabetical order. So the name of this structure is 6,7 dibromo. 6,7 dibromo. Now we'll move on to 2-chloro. 2-chloro, because chlorine is attached to the 2nd carbon atom. And then on the 3rd carbon atom, you have 3-methyl. Let me wipe this off. We don't need it. Okay, 3-methyl, 3-methyl. And the longest carbon chain is 9. 9 in alkane is nonane. You know, these are all single bonds. So it's an alkane family, so nonane. Alright, that's the structure of this. There is no alternative to this because we do not have all these iso or sec or tet attachment there. We didn't have them. Alright, we're going to take a short break. When we come back, we'll look at the next structure, number 8. And now, the last structure. With these, we would have come to the end of IUPAC nomenclature for alkanes. And believe me, once you're able to understand all we've done for that of alkanes, it means you've actually covered 98%. Yes, 98% of the IUPAC nomenclature of aliphatic compounds. Because when you go to other homologs, alkene, alkynyl, alkanol, alkanoic acid, I mean, those ones are simple. Any complexity is still based on all these alkyl attachment, and of course, where to count from in some of all those other homologs is very simple because they have defined functional group. Don't worry, when we get there, we'll cross the bridge, okay? So let us identify our carbon atoms here. This is carbon, this is carbon, this is carbon, this is carbon, 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 and carbon. And of course, we have carbon here. Let me use a blue marker for this. We have carbon. This is a CH3 group. Is that okay? Now, take note that ordinarily looking at this, the longest carbon chain should go in that direction I've identified already. But you would notice that this is an attachment. And there is a carbon here as well. So have carbon, carbon. Is that okay? And this carbon is linked to this parent chain here. We have carbon here. And we have carbon and carbon here as well too. Good. We've identified all these. We've identified all of them. Please take note. At the end of this, we are going to release the carbon skeletal structural system for this. That is how it should have looked like in this format with carbon being shown. To get information about that, please, we urge you to follow us on our Facebook page at GMATS41, as well as our Facebook group at GMATS41 Get Academic Help and Mentorship for Students. You can easily type that from your timeline and see that on Facebook. Follow us so that you get information on how to get the notes of this. On how to get the notes, the carbon skeleton. Even most of other of our notes would give out the link on how you can access those notes. Alright? Remember to help us share the link so that students can get to know of what we do and join GMATS 41 in order to add sustainable values to their education. We are just here to give people the best we can. A splashes. Now let us go. The longest carbon chain here, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's still 9. But where do we come from? I perceive it's going to be here because the first attachment is on the second carbon atom here. So that goes as 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright. Having identified that, let's now get our attachments. This is an attachment. This point we have an attachment. This is methyl CH3. Then look at this whole thing is an attachment. You have two carbons there. Alright, two carbons. You can see, in fact, let me show you something. The way this is attached is something like this. CH2, CH3. Because there is no two branches from this carbon. It's only one branch from this carbon, which is this. CH3. So it's actually ethyl attachment, okay? Then this is also an attachment. This is an attachment. Now this is carbon. This is carbon here. This is carbon. Is that okay? You take note that on this carbon there are two branches. So what does that tell you? It tells us that that is a substituent and substituent. And once you're able to analyze this pretty good, your problem is far solved. Is that okay? It's almost solved. That's just the point. So let us see how we can now give the nomenclature on this. This is methyl, like I said. Now look at this. If this is carbon atom number 1, because we need to number this again as 1, 2, and what? 3. So on the first carbon atom, we have this methyl. Look at it. This one now is like our grandchild, Mr. C. This carbon atom number 5 is Mr. A, the main parent. Then this carbon atom number 1 is Mr. B. Do not forget that illustration. It's a powerful one. Is that okay? So this is actually 1-methyl propyl. On the first carbon atom, you have CH3, so that is methyl. 1-methyl propyl. Is that clear? And of course, you know that 1-methyl propyl, it follows the IUPAC system of naming. It has its own old name. Its own old name. How many carbons all in all if you count? 1, 2, 3, 4. So this is a form of isomeric butyl. But 4 carbon atom is but. Alkyl, butyl. But this is not isobutyl. It's not isobutyl. Because it's a secondary compound. So it's actually sec-butyl. Our previous video we've actually explained that. And you can please visit our YouTube channel. Okay? Visit our YouTube channel, subscribe. This particular issue of our alkyl substituent had been released through our YouTube channel. Okay, so let's give first the IUPAC nomenclature directly following IUPAC system. I think the first attachment we're going to consider is chlorine, because chlorine comes before C, comes before E. This is C, this is E, this is N. And then you now have this attachment, 1-methyl propyl. So we go. On the third carbon atom, I have chlorine, so that is 3-chloro. Then after that, on the sixth carbon atom, I have ethyl, that is 6-ethyl. Then, look at, we now have the issue of whether naming this methyl first or 1-methylpropyl. And we've already explained that in structure number 1. This is 2-methyl. Methyl, it's taught at that spelling, L at the end. But this one is 1-methylpropyl. If you are to search for methyl and 1-methylpropyl in the dictionary, which one will you see first? Methyl. Alright, so it means that 2-methyl will come first. 2-methyl will come first. And then we go to, on the fifth carbon atom of the parent, we have substituent on substituent. So you put that in bracket, and that is 1-methylpropyl. 1-methylpropyl. The longest carbon chain is nonane. Alright? We are going to take a short break. When we come back, we'll give the alternative name to this using the sec-butyl common name to this part of the attachment. Alright, so we want to look at the common name of this structure, considering the fact that this part of the attachment has a common name, otherwise known as old name. Remember, we've urged you, please follow us on our Facebook page at GMAT41. You can also follow us at join the GMAT41 Get Academic Help and Mentorship Group on Facebook, so you can get access to our notes, quizzes, and interaction between tutors and students. Now, this structure, we want to give an alternative name to it, which is not completely different from this, but just a little adjustment, just like we saw here and here, that is in these two structures. Now, what should we know about this? This is where we want to touch, we want to work in this. Take note that in the IUPAC system, this is 1-methylpropyl, as we mentioned. 1-methyl is attached to the first carbon atom here, then propyl. But all in all, how many carbon atoms do we have here? 1, 2, 3, 4. So this is like boots, but this is not normal butyl. So if you pronounce this to be 5-butyl and whatever, it's really not in line with IUPAC rule. Is that okay? This is something, a form of secondary butyl. I wouldn't call it isobutyl because it's not isobutyl. Let's try to expand the structure and see what it looks like. This is carbon that is directly attached to the parent chain. Okay, this is directly attached to parent carbon number 5. Then, remember it is linked to a carbon here, so we have CH. This carbon here is actually CH2. Then linked to this carbon, this terminal carbon here, that's the last carbon, is CH3. Then you take note that to the left hand side of this carbon here, you have another CH3, this terminal carbon. Is that okay? So this is actually, looking at this carbon will have hydrogen here. Is that okay? To have hydrogen here. This structure is actually sec-butyl. That's how it's being pronounced. Is a secondary alkyl attachment. Secondary because the carbon that is directly attached to the parent has 2 alkyl groups attached to it. These are the alkyl groups, okay, attached to this carbon that is directly linked to the parent. So it is a secondary alkyl attachment. Please, we urge you and we plead that you visit our YouTube channel to this and then subscribe. As we upload videos in this, it's going to guide you very, very well. And let's move on and see. So you see why this is not normal butyl. If it were to be normal butyl, this is what we would have. If it were to be normal butyl, the structure would be something like CH2, 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 and then CH3 to be linked to CH3. Please, this CH3 is a continuation. Then this carbon, this will be directly linked to parent carbon number 5. All of this have been explained in our previous classes. So why I went to say all this is because this butyl structure is actually a secondary butyl, which is pronounced sec-butyl, and italicized if you're actually writing it. So let us see how it goes. Are we ready? Now, when you're dealing with sec or tertiary butyl, sec or tertiary alkyl group, you recall that I stated in the previous class that the sec or the T-E-R-T is dropped. It does not follow the alphabetization rule, which means if this is sec butyl, the sec will be dropped. That is, if you want to follow the alphabetical rule, the sec will be dropped. You only pick the butyl, and butyl starts with what? B. Looking at all these attachments, this will now become B attachment, this will become C attachment, this will become N attachment, this will become E attachment. And which one will come first? B. Is that not so? Therefore, in this structure will start. So I'm going to write OR. I'm going to put, let me write OR here. On the fifth carbon atom of the parent, we have sec butyl. So I'm trying to italize my sec. I don't know. Very funny, right? So sec butyl, and this is how you write it. Okay? The sec and the butyl, there is hyphen between them. And remember, between number and alphabet, you put hyphen as well too. So done with that, sec butyl. We'll now move on. Third carbon atom, we have chlorine, so 3-chloro. What's the next attachment? On the sixth carbon atom, we have 6-ethyl. And then on the second carbon atom, we have methyl, 2-methyl. We can now conclude with nonane. So that is that about the IUPAC nomenclature of alkanes. It's pretty simple. If you're able to go through the 8 structures that have been treated so far from GMAT 41, watch the video over and over again, grab the point, then you are good to go in IUPAC nomenclature. In our next class, we are going to look at the IUPAC nomenclature of alkenes and alkynes. We'll treat both together in our next class, because the whole principle about IUPAC nomenclature has been constructively analyzed under alkane.